Howdy folks, unit circle time. Before we look at coordinates on the unit circle, I'm going to go through a quick derivation on how we think about the unit circle. Remember unit circle, this is a radius value equal to 1 unit. And we sketch out a triangle like this, right? We know this is 30 degrees, okay? 30 degrees or pi over 6 radians, okay? Over to the other page, a little bit of basic trigonometry. 30 degrees, I'll do the same thing with radians, right? Because you need to know how to go back and forth. Pi over 6 radians. Unit circle 1, right? How do I get this x and y value? X and y value. Trigonometry time, right? And this is the basis for how we get all our values of our unit circle. How do I get the y value? That's the sine of 30 degrees equals opposite over hypotenuse. So the sine of 30 degrees equals y. Make sure you're in degree mode. If you type in sine of 30, we want exact values, folks, right? So make sure you're in degree mode, and then you go sine of 30, y equals 1/2. Okay. Oops. What about our x value? Well, our x value, right, we can use either another trig ratio, or we can use Pythagoras. So x squared plus y squared equals 1 squared. So x squared plus 1/2 squared equals 1 squared. That's x squared plus 1/4 equals 1. X squared equals 1 minus 1/4. X squared equals, and let's combine by making equivalent fractions. So that's 3/4. And I take the square root, right? Note that this is a positive value for x, positive value, because I'm on the positive side of the x-axis. So I'm going to ignore the negative value for now because I'm looking for the positive value. X equals the square root of 3 over 4, and x equals the square root of 3 over 2. Okay, and then if you do the same with radians, you can do the same sort of calculation in radians. Make sure you're in radian mode. So I'm going to go to radian mode. Okay, and I go sine of pi over 6 equals y over 1, opposite of our hypotenuse. That's sine of pi over 6 equals y, and it's still 1/2. Make sure you're in radian mode when you do this. So sine of pi divided by 6, I get 1/2. And you go through the same calculation here using Pythagoras, okay, and you get an x value of square root of 3 over 2. All right, so this is a brief primer on how do I derive some of these exact values from the unit circle. Let's go back to the unit circle, and let's start filling these values in. Okay, so we said this is calculated as a coordinate value of square root of 3 over 2 and 1/2. Okay, if we go back down, right, so let me just erase this. Remember, this is our unit circle. If we start at the origin and trace out an initial arm here, and the terminal arm ends right there, this is also known as 0 degrees. Also 360 degrees if we do a full circle. This is also 0 pi or 2 pi. And the coordinates here are 1, 0, because the radius here is equal to 1, and we haven't moved any vertical direction, right? So it's 1, 0. And then when we step up to this part right here, this angle, we calculated the value as square root of 3 over 2 and 1/2, and 30 degrees or pi over 6 in radian values, okay? Let's fill in the rest of this unit circle, and you'll start to see a nice little pattern emerge. So when we go to 45 degrees, we know that's pi over 4 radians, right? By now, if you're getting enough practice in, you'll know these radian values quickly. Well, that's square root of 2 over 2 and square root of 2 over 2. This point right here. Okay, let me just write the points there. Okay, when we step up here, this is 60 degrees, folks. That's pi over 3 radians. And I know that's 1/2 and square root of 3 over 2. So it's like this. 1/2. So the x value is 1/2, or cosine of theta is 1/2. And the y value is square root of 3 over 2. So sine of theta is square root of 3 over 2. Think of it that way, the x and y values. Okay. All right, continuing. I go all the way up. First quadrantal angle, this is 90 degrees, also known as pi over 2 radians. That's 0, 1. So 0 on the x-axis, and then I go 1, which is the radius of the unit circle, right up to this point. So that's the point, coordinate point 0, 1 at 90 degrees, or pi over 2 radians. Keep going. This is where you start to see your first pattern. If I draw this point across, it's at the same level as square root of 3 over 2, so the y value must be square root of 3 over 2. Okay, square root of 3 over 2. And then you'll see that the x value is just a negative of the x value from the other side, so that's negative 1/2. This is 120 degrees, or 2 pi over 3. So pi over 3 at 60 right here, and then 2 pi over 3 at 120 degrees. Okay, use the same sort of logic we did here to build the rest of this unit circle. So I start here. Well, that matches there. This is 135 degrees, or 3 pi over 4. And I have the same y value, square root of 2 over 2. And this is negative square root of 2 over 2. Okay, continuing. That's 1/2, but it's negative square root of 3 over 2. And then this is 150 degrees, or 5 pi over 6. Okay, finally make 1/2 rotation around the unit circle. This is negative 1, 0 right here. This is 180 degrees, or pi radians. Okay, continuing. If I look at this relationship here, I bring it down. This is the same negative x value. So I'll say negative square root of 3 over 2. Except now I'm going down 1/2, so it's negative 1/2. So all these coordinates in quadrant 3 will be negative. Okay, and this is also known as 210 degrees and 7 pi over 6. Okay, how do I know it's 7 pi over 6? Well, I know this, also known as 6 pi over 6. Well, it's just pi over 6 more to get to this next spot here. So it's 7 pi over 6. Okay, that's a quick and easy way to remember that. All right. Next one. So if I draw this guy down, well, that's at the same x value as negative square root of 2 over 2. So I got negative square root of 2 over 2 and square root of 2 over 2. Oops. And negative square root of 2 over 2, because I'm going down. And that's 225 degrees. And that's 5 pi over 4. Okay. How do I know it's 5 pi over 4? Well, use that half rotation of the circle, the pi value, as your reference. This is also known as 4 pi over 4. If I go halfway through the quadrantal angle here, this is 45 degrees, or I know it's pi over 2, well, pi over 2 this is pi over 4, sorry. So if I go halfway through the quadrantal angle, 45 degrees, that's pi over 4. I add that to 4 pi over 4, which is just pi. I get 5 pi over 4. So that's a quick and easy way to remember, how do I get 5 pi over 4? Okay. All right. Continuing. So you see the pattern developing here. This would be -1/2 and negative square root of 3 over 2. And that's 240 degrees and 4 pi over 3. Okay, down to another quadrantal angle. This point right here, this is 0, -1. This is 270 degrees, one of our quadrantal angles, and this is 3 pi over 2. How do I know it's 3 pi over 2? Every time I go one quadrant in an angle, so 90 degrees, that's pi over 2, folks. Okay, 1, 2, 3. I've done 3 quadrantal angles, therefore it's 3 pi over 2. Okay, and continuing. So keep going on down the line. You can do this relationship here. It's at the same level for the y value, so I know it's negative square root of 3 over 2. And then it's positive 1/2 this time because we're going on the positive x-axis. Okay. Okay. This is also known as 300 degrees. And I know this is 5 pi over 3 because the previous 60-degree point right here, that's 4 pi over 3. Oops. Okay, so this one, if I go from here, 30 degrees, right, from 240 to 300, that's another pi over 3, so that's 5 pi over 3. Okay, almost around to the end. So this is 315 degrees, midway through our quadrantal angle. This would be square root of 2 over 2, negative square root of 2 over 2, 7 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4, 7 pi over 4. Okay. Lots of patterns going on here. Last one here, 330 degrees. That is square root of 3 over 2 and negative 1/2. This is 11 pi over 6. How do I know it's 11 pi over 6? Well, if I go all the way to the end here, I know this is 30 more degrees, or pi over 6 more. So 2 pi is also known as 12 pi over 6. Well, I'm going to go 30 degrees less than that, or pi over 6 less than that. So this one must be 11 pi over 6. Okay, and we've done a full rotation of our unit circle. So I'm going to zoom out. And there we have it, folks. Okay, one thing to note about our unit circle, the point, any point on the unit circle, we can show with the coordinates cosine of theta, sine of theta. So these are our Cartesian coordinates, and this is our point x, y on the unit circle. Alrighty? Okay. Let's do some problem solving here. Next page. Okay, folks, this is again back to Desmos, the unit circle, multiples of pi over 6. It's our most common multiple that we use. Sorry, it doesn't include pi over 4, but not that difficult to understand. So at 1, 0, right click, there's pi over 6, pi over 3, or otherwise known as 2 pi over 6, 3 pi over 6, or pi over 2. Right? These are the values we looked at. Again, I'm sorry, we're missing, the only thing we're missing is the pi over 2. So, sorry, pi over 4, which would be square root of 2 over 2, but you get the idea. So there's our wonderful animation, stepping through the unit circle in pi over 6 radians at a time. Oh, next page. Okay, the unit circle. The equation of the unit circle is x squared plus y squared equals 1. This is what we showed from our Pythagoras example right here, folks. Remember this one? right? I even use Pythagoras right here to solve for the unknown side x right here, okay? So it should make sense that the equation of the unit circle is x squared plus y squared equals 1. And then what is the equation of any circle with radius r at center 0, 0? Well, that's just x squared plus y squared equals r squared. Good old Pythagoras, okay? Determining coordinates for points on the unit circle. Which quadrants is the x-coordinate positive? Well, we know that's quadrant 1 and 4. Negative? Well, the other ones, quadrant 2 and quadrant 3. Which quadrants is the y-coordinate positive? Quadrant 1 and quadrant 2. And the y-coordinates are negative in quadrant 3 and quadrant 4. Example 1. Is the point negative 3 1/4 on the unit circle? What about square root of 7 4 comma 3 4? Explain how you know. So if a point xy is on the unit circle, it will satisfy the equation x squared plus y squared equals 1. So let's take a look. For this one, negative 3/4 squared plus 1/4 squared. Does it equal 1? That is 9/16 plus 1/16. Does it equal 1? Well, that is 10/16. Does not equal 1, so not on, I'll say UC, not on unit circle. Okay? What about the other one? Square root of 7 over 4 squared plus 3/4 squared equals 1. Does it equal 1? That is 7/16 plus 9/16 equals 1. 16/16 equals 1. That is 1 equals 1. This is on the unit circle. Check. Okay. Example 2. Determine the missing coordinates for all points on the unit circle satisfying the given conditions. Sketch a diagram and state which quadrants the points lie in. So I have A, negative 5/8 y, so we are telling you that it is on the unit circle, this coordinate A. What is the coordinate, what is the missing coordinate? And then tell me the quadrant that it could lie in, okay? A, so I have negative 5/8 squared plus y squared equals 1. That's 25/64 plus y squared equals 1. That's y squared equals 64/64 minus 25/64. Y squared equals 39/64. Exact values, folks, okay? So this is y equals plus minus 39 over 64. And that's y equals plus minus 39 over 8. Okay, so if I draw my diagram of a unit circle, okay, there's my unit circle, and I have negative 5/8 is somewhere around here. Here's that point. This is negative 5/8, positive 39, square root of 39 over 8. And then the other point would be in quadrant 3, which is negative 5/8, comma, negative square root of 39 over 8. Okay. So where would it lie? This is quadrant 3, and this is quadrant 2. Okay, letter B. I have a point x, comma, negative 5/13 where the point is in quadrant 4. Now I'm telling you which quadrant it is in. I just need the coordinates. Okay, so I have x squared plus negative 5/13 squared equals 1. That's x squared plus 25 1/69 equals 1. That's x squared equals 169 1/69 minus 25 1/69. That's x squared equals 144 1/69. That's x equals plus or minus square root of 144 over 169. Got some perfect squares going on. X equals plus or minus 12 over 13. We want quadrant 4 only, so the x value in quadrant 4 is positive, so I'm going to only use the positive value. So this is going to be in quadrant 4, right? So let me draw a diagram here. Here's my unit circle. Okay, start the origin. I'm going to negative 5/13, and then 12. Sorry, oops. This should be an x value. Sorry, folks. 12/13 and a y value of negative 5/13, which is in quadrant 4. Okay. Next page, folks. Example 3. If the point P of theta is the point at the intersection of the terminal arm of angle theta and the unit circle, determine the exact coordinates of each of the following. Okay. This is, I like to think of it this way. 8 pi over 4 is 2 pi. That's one full rotation. Okay. Plus pi over 4 more gives you 9 over 4. Okay, I like to think of it that way, so when I sketch my angle out here, this is what it looks like. Okay, start at the origin. Here's my initial arm. It's a positive angle, so I'm going to go one full rotation plus pi over 4 more, which is halfway through our quadrantal angle. There's my terminal arm. This is theta equals 9 pi over 4. Okay, 9 pi over 4 is coterminal with pi over 4. So I know this point has to be on the unit circle. The coordinates on the unit circle is square root of 2 over 2, square root of 2 over 2. Okay. B, negative 4 pi over 3. So I think of it this way. Negative 3 pi over 3 equals negative pi. This is a half rotation. Okay, half rotation plus negative pi over 3 more. Okay, which gives you negative 4 pi over 3. This is the way I think about it. So when I draw this out, okay, it's a negative angle. So I'm going to start at the origin. Here's my initial arm. I'm going to go clockwise. Okay, so negative 4 pi over 3. So pi over 3 is 60 degrees. So I'm going to go 3 times 60. So, oops, sorry. Okay, so I'm going to go 3 times 60 here. So that's 1, 2, and then 3 times 60. Sorry, 4. Let me back this up. Sorry about that. 4 times 360. It's 4, negative 4 pi over 3. So this is 1 of the 60. This is the 2 of the 60s. This is the 3 of the 60s, and then 4 of the 60s. Okay, let me just be super accurate here. I'm going to go up. Okay, this is where it ends. Okay, negative 4 pi over 3 is, oh man, bad head. Hold on. Negative 4 pi over 3 is coterminal with, well, that's just 2 pi over 3. And I know my point here on the unit circle, the coordinates must be negative 1/2 square root of 3 over 2. Okay, let me write those coordinates, and this coordinate should be this guy right here. Okay, Example 4, state two different possible measures for the rotation angle such that point A, negative square root of 2 over 2, and negative square root of 2 over 2 is on the terminal arm of theta. Can a general statement be written to express all solutions? Yes, of course. Okay, so first of all, where is negative square root of 2 over 2 and negative square root of 2 over 2? So if I draw this out, oops, here's my initial arm, right? And I sweep all the way over here. That's halfway through my quadrantal angle in the third quadrant. Well, that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, so theta here equals 5 pi over 4. So my principal angle, remember that, principal angle is 5 pi over 4. What's an angle that's coterminal to 5 pi over 4? Okay, so I go 5 pi over 4 plus 2 pi times 1. I'll pick an n value of 1. That's 5 pi over 4 plus 8 pi over 4. And that's 13 pi over 4. Okay, generally I can say 5 pi over 4 plus 2 pi n, where n is an element of all integers, n does not equal 0. Okay, so here's my general statement to express all the angles that have this coordinate on the unit circle. Okay, last example, example 5. Determine the length of the arc on the unit circle that starts at point A and ends at point B after 3/4 of a full positive rotation. This is interesting. Okay, a little bit more of an integrated problem. Let's draw this out. Point A starts at negative 1/2 square root of 3 over 2. So negative 1/2. Let me draw my unit circle here in red. Okay, negative 1/2 square root of 3 over 2. This is point A. So this is negative 1/2 square root of 3 over 2. Okay, and then we're going from point A to point B after a 3/4 of a full positive rotation. Okay, so first of all, 3/4 of a full positive rotation is 3/4 times 2 pi, and that is 6 pi over 4, or 3 pi over 2. So I'm going to go 1.5 times a half rotation. So 1.5 rotations, or it looks like 3 quadrantal angles. So 3 90-degree rotations, right? So first of all, I know point A is at 2 pi over 3. So this tells me A is at 2 pi over 3. Okay, because I know those coordinates tell me the 2 pi over 3 value. Okay, so I'm going from 2 pi over 3, so from A at 2 pi over 3 radians, I need to add 3 pi over 2, which is the 3/4 rotation that I just calculated here. Remember, we're going in this direction, positive, so add 3. So what does that look like? So 2 pi over 3 plus 3 pi over 2. That's 4 pi over 6 plus 9 pi over 6. That equals 13 pi over 6. Okay. So what that means is that from 2 pi over 3, so if I start here, folks, right, and I rotate from 2 pi over 3, I add 3 pi over 2, I'm going to end up at 3 pi over 6. That's like saying 13 pi over 6. That's like saying 12 pi over 6, which is at the 0 mark, or the 360 mark, plus pi over 6 more. So I'm going to go all the way until I meet the 360 mark, then pi over 6 more, and then that's point B. Okay, so this amount is 3 pi over 2. Okay, that's how much we added, and then we end up at point B. We end up at point B. Oops, let me do this so it's not confusing. We end up at point B, folks, which is, if this is pi over 6, this is pi over 6 right here, right? I know that that point is 1/2, sorry, square root of 3 over 2, comma 1/2. Okay, did we answer the question? State the coordinates of B. We did. So coordinates of B are square root of 3 over 2, comma 1/2. Okay.